Adding and subtracting square roots. Let's begin by talking about adding and subtracting square roots where the value under the square root is actually the same. So for example, how would you add 4 the square root of 2 plus 3 the square root of 2? That's what adding and subtracting like radicals, where the value under the radical is the same. Well, that's the same thing as adding 4x plus 3x. If you remember that, you can factor an x out. If you factor an x, what's left? 4 plus 3. And if you do what's inside the parentheses, that's x times 7, which is the same as 7x. So when you're adding 4x plus 3x, just add the numbers and keep x. Well, we're going to apply the same logic. The fact that these two are the same here, we're going to add the numbers. What's 4 plus 3? That's 7. And we keep the square root of 2. That doesn't become the square root of 4. Again, the reason you can factor, here's the reason why. You can factor the square root of 2 out, and what's left? It's 4 plus 3. And what's 4 plus 3? It's 7. And I like to add the 7 first. But you don't have to do all these steps to get to the answer. Just add the two numbers in the front and keep the square root. So let's take a few examples. 5, the square root of 3 minus 2, the square root of 3. What is 5 minus 2? That's 3, and we keep the square root of 3. What is 7, the square root of x minus 2, the square root of x minus 4, the square root of x? Again, they all have the square root of x, the same thing. So we take the numbers in the front. What is 7 minus the 2? That's 5. 5 minus 4 is 1, and we keep the square root of x. You don't have to write the 1, so this becomes the square root of x. What is 4, the square root of 2y plus 1 minus the square root of 2y plus 1? Notice the second radical does not have a number in the front, which really means it's a 1. We just don't put it. So now, what is 4 minus a 1? That's 3, and we keep the square root. What is 4, the square root of 6 minus 2, the square root of 2? Notice these are different, which means what? Can't be combined. You can't. The reason? The value under the square root is different. Okay. Well, not every problem is going to have like radicals, the same thing. Like this one, these are unlike radicals. That doesn't mean every unlike radical can't be combined. So let's look at that. Adding and subtracting unlike radicals. So the value under the square root is not the same here. Let's try this one. What is the square root of 12 minus the square root of 27? Quickly we see these numbers are different, so I can't really add them or subtract them yet. Well, let's see if I can simplify that. 12 can be written as 4 times 3. So I can take the 12, break it down to 4 times 3. The 27 can be written as 9 times 3. If you remember, with radicals, if you have a multiplication, you can break it down to the square root of 4 times the square root of 3 minus, this will be the square root of 9 times the square root of 3. And what is the square root of 4? The square root of 4 is just 2, and there's the radical of 3. And what is the square root of 9? That's 3 radical 3. Now these are like radicals. So 2 minus 3, which is what? Negative 1, the square root of 3. We never have to write the 1, that's minus the square root of 3. Let me try another one. Seven times the square root of 50 minus the square root of 32 plus the square root of 72. Now again, I'm going to apply the same logic. See if I can break the 50 down. Well, 50 is 10 times 5. The problem with 10 and 5, I have no idea what the square root of 10 is or the square root of 5. So these two numbers are not good choices. 50 is also 25 times 2. So I can break it down to the square root 25 times the square root of 2. And I chose the 25 is because I know the square root of 25. The square root of 25 is what? 5. And there's the square root of 2. What is 7 times 5? 35, the square root of 2. That's the first one. Let's look at the minus here. 32. 32, I can break the 32 down as 16 times 2. That's 32. Which you can break it down to the square root of 16 times the square root of 2. And what is the square root of 16? That's a 4, the square root of 2. Plus 72, 8 times 9. 9 is good. 8 can be worked on. Or I can use 36 times 2. That'd be a better choice. 36 times 2 is 72. I can break it down to the square root of 36 times the square root of 2. What is the square root of 36? That's 6, the square root of 2. Now they all have the square root of 2 in them. So your answer is going to be what? 35 minus the 4 is 31. 31 plus 6 is what? 37, the square root of 2. Let's try negative 3, the square root of 16t plus the square root of 9t. Here's the negative 3 in the front. Square root of 16t, I can break it down to the square root of 16 times the square root of t. The square root of 9t, I can break it down to the square root of 9 times the square root of t. This will be negative 3, square root of 16, which is 4, the square root of 9, which is 3, negative 3 times 4 is negative 12, the square root of t, plus 3 the square root of t. What's negative 12 plus 3? That's a negative 9 the square root of t. The square root 20 minus the square root of 5. Again, 20 can be broken down to 4 times 5. Which I can break it down to the square root of 4 times the square root of 5 minus the square root of 5. What is the square root of 4? That's a 2 times the square root of 5 minus the square root of 5. Notice again, there's no number here, which means it's a 1. 20 minus 1 is 1, and we keep the square root of 5, and you definitely don't write the 1. Your answer is the square root of 5. A couple more examples. Let's try that. Let's try this. A times the square root of a squared b minus five b the square root of b. That's it. Well, I can break this one, there's the a in the front, to the square root of a squared times the square root of b minus, here's the 5b, I can't touch it, and there's the square root of b. And if you remember the square root of a squared, you take the power and you divide it by 2. When you divide 2 by 2, that's a 1. A times a times the square root of b minus 5b the square root of b. That's a squared and usually you want to combine the a squared minus 5b, but you really can't put them together. So the only thing you can do, you can say, you know what, I can factor out the square root of b. If I factor square root of b, what's left? A squared minus 5b. And me personally, I like to write this one first. So I will write my answer as parentheses a squared minus 5b close parentheses times the square root of b. That's as far as I can go with it. Another one like this, one more in there, then that's it. 25 ab to the fourth plus 7b squared times the square root of a. Now this one I can break it down to the square root of 25 times the square root of a times the square root of b to the fourth. What is the square root 25? That's a 5. What is the square root of b to the fourth? Take the power and divide it by 2 is b squared times the square root of a. Now remember, you're multiplying two things. Which two you multiply first doesn't really matter. So what is 5 times b squared? That's 5b squared. I'll put them in the front. The square root of a plus 7b squared, the square root of a. Notice these two are identical, so I can combine them. What is 5 plus 7? That's 12b squared, the square root of a. When you add, you don't touch your exponents. You leave them alone. And that's the final answer to this problem. So that's how we add unlike radicals. We'll see if we can make them the same by simplifying them first. And if we can, let's go ahead and simplify them. Then hopefully you end up with the same thing on both sides or next to each other. You can group them together and make it one piece out of it.